Add and subtract rational expressions. So last time we did some simplifying and we did multiply and divide, and basically what we looked at for that was getting out common factors. For adding and subtracting, think back to when you added and subtracted fractions. When you added and subtracted fractions in the past, and you know what? It was actually really easy if you had a common denominator. 3/8 plus 5/8, or 3/8 plus 5/8 is 8/8. Hey, that reduces to 1, not a big deal. Too bad. Subtraction, 5/6 minus 1/6, 4/6. That one we can reduce to 2/3. Sometimes when you added or subtracted, you got an answer you couldn't reduce. Okay? But if you could reduce, you did. Okay? When it comes to expressions, we're going to add and subtract them. We need to have this common denominator. And when I get my final answer, if I can reduce it, I will. Back to what we did last time. If I can't, then it's fine. Okay? Where we run into a little bit of a problem would be if we did not have a common denominator. So let's do something like this. 3/4 plus 5/6. So this would be an old one, not common. Our first job was to get a common denominator. Okay? So we were thinking of a value that both 4 and 6 go into. Lowest common denominator would be 12. 6 and 4 both go into 12. So we go, all right, 3. And we were thinking, what did we multiply 4 by to get this? That was 3, so I got to multiply that numerator by 3. 5. What do we multiply 6 by to get 12? That's 2, so I had to multiply 5 by 2. And then 9 and 10s, 19 twelfths, and I can't reduce it. So we had to get a common denominator sometimes. If it was a subtraction problem, if I just change this to subtraction, I still need a common denominator. Okay? So it'd still be this subtraction, okay? Which means we just have -1. I can still subtract that piece. So take a moment, see what you come up with for these two. Now we're going to switch to an expression. Let's go 2x plus 1 over 5 plus 3x minus 7 over 5. And let's go 5x minus 2 over 3 minus 2x plus 1 over 3. Think about what you get. Their common denominators. That's what we wanted. Right? So think back to the numerical ones. On a numerical one, you just dealt with the top. Right? Yeah. Okay, that's fine. They got a common denominator and go straight across. It's nice when they're both the same. 2x and 3x is 5x. 1 minus 7 is -6, all over 5. I can't reduce it. Remember, we can't take out what looks good. I don't have a common factor. So I'm kind of stuck there. It's from last class. If I subtract, 5x minus 2x is 3x. -2 minus 1 is -3 over 3. Okay? So one of the things you want to remember on the subtraction is, remember that negative distributes. Think of that numerator as being 5x minus 2 minus the 2x plus 1. That negative is going to distribute. Now I look at this one and I can reduce this one. Notice they all have a 3. Okay, so you can even think of it from last class how we factored a 3 out. 3 times the x minus 1. 3's cancel. And just x minus 1. Now we really don't care what the denominator is. Our focus is it the same? So on those two problems, each one of those I have a numerical denominator. If I switch it to a variable denominator, something like 8x over x plus 2 minus x plus 1 over x plus 2, I'm not going to let it bother me. My concern is, are the denominators the same? And yeah, they are. They're both x plus 2's. No problem there. I have a common denominator. If I have a common denominator, I can go ahead and just put the top together. 8x minus x is 7x. And minus 1's minus 1. Don't forget to distribute the negative. Pretty basic when I have that common denominator. Similar to what we had over here. I got a common, I can go straight across in the numerator. I don't care if the denominators are numerical or variable format. What I care about is if they're the same. If they're the same, I've got them. Our biggest problem came in situations like this, where we have an unlike denominator, we have to get a common. Okay? Problem gets pretty simple from here to here, not much going on, but getting that common denominator and building the numerator is where the trouble came in. So that's what we're going to work with when we have an unlike denominator. Unlike denominator, get one up here. Let's do 3x. This is number 4. 3x over x plus 1 plus 4 over x minus 1. Now, in a variable format, it's a little different getting a common denominator in variables. In numbers, a lot of times you're just trying to think, all right, what do those two numbers go into? Smallest value they go into. On a variable one of the easiest ways to do it, write the first one down. Because if it's there, it's in the common. Then you go to the next one. And my next denominator, I see an x minus 1. And I have to think to myself, do I have an x minus 1 down here? I don't. So yes, it's in the common. Right, so to repeat, it's our process every time. Write the first one down. Go here. If you've got it, you don't need it. If you don't, you need it. I don't have it down here. Wrote it. Now my numerator. 3x. What we always thought of, and it was true, what did we multiply this guy by to get this? That told you what to multiply the numerator by. With variables, it's still the same thing. What am I multiplying this by to get this? But it's also a little more visual. What's different here than right here? Well, this one's got an x minus 1 in it. This one doesn't. So that tells me, put an x minus 1 right there. Because that is what I multiplied by. Now I'll go to the other part. 4. And my focus is right here. I'm looking right at that denominator. What does this common have that that does not have? The x plus 1. There's my setup. Everything else now is just the grunt work of putting it all together. Stuff that we've done many times before. So we're going to distribute the 3x, distribute the 4. So I'd have 3x squared minus 3x plus 4x plus 4 over x plus 1, x minus 1. Now I can still put some like terms together there. I got 3x squared plus x plus 4 over x plus 1, x minus 1. Now, what should be locked in your mind by this point? especially after last unit. If you have a square, you better think about if it factors or not. Okay. This one is not going to factor because I can't split a 4 to get a 1 in the middle to cancel, but it still needs to enter my thought process. If something needs to be factored, I need to take care of it. So anytime you see that square, you should know in your mind there is a chance. So let's look at something like this. X minus 3 over 2x plus 6 plus x plus 2 over x plus 3. So this will give us a little bit of that factoring idea. When I look at that first denominator, the 2x plus 6, I can factor that. Always check and make sure your denominators are in lowest terms. And when I look at this guy, I can actually factor that to 2 times x plus 3. I need to know what I'm dealing with. I need that simplified form. For the previous section, when you simplified, multiplied, divided, you got it factored out so you knew what you were dealing with. Same thing's happening here. If something factors, take care of it. Well, now I'm looking at this and going, all right, I need a common denominator. Boy, they look close, but they're not the same. One of them's got a 2 there. So to get my common, here's your process again. Write the first one down. 2 and x plus 3. Always write the first one down. Then I'm looking at the second one. And when I look at the second one, I got to decide, do I already have an x plus 3 down here? I need it. Well, I already have it. So I don't need another one. I've got it. Now I go to my numerator. I've got x minus 3. And it's what did I multiply the original denominator by, or that visual aspect we're looking right here. Hey, what's different between this purple one and this one? Nothing. So I'm not going to multiply that numerator by anything. When I get to the other side, x plus 2, okay, now I'm looking at this black x plus 3, this black common denominator. What's different between this one and this one? Well, this one's got a 2. So that means I need to multiply that by a 2. And now I've built everything. So this is our part we've got to focus on getting built. From this point on, it's multiplying, combining like terms, and stuff we've done. So this would be x minus 3 plus 2x plus 4. Distribute that 2. Which would be then 3x plus 1 over 2 times x plus 3. And that's not going to simplify. We're good there. We don't ever have to multiply the denominators back out. You can. It would never be counted wrong. But usually if you think about last unit, or last thing we did, we usually like it in that factor form because we can see domain. It's sitting there. So we usually just leave it in that factor form. Let's get a different look here. Let's go. Let's go a minus 3 over a squared minus 5a. Mix some different variables in here because it doesn't matter what we have for variables. A minus 9 over a squared minus 25. You too. Look at the denominators. They've got to be factored. We see those squares. We can see a common factor in the first one. We've got a difference of squares there. Get the 2 denominators factored out. We've got to know what we're dealing with. Take a moment, factor each denominator out right below it so we know what we're working with. Is it right? What? Is it right? All right. Get both denominators factored. All right, everybody agree with these two factors? A minus 5 and a plus 5, a minus 5. Okay, now stick to the process for the common. Okay. It looks like it's going to be a mess because we see everything going on up there. Our job was to get that common. We write the first one down, a minus 5. If it's in the first one, it's in the common. I write it down, get it out of my way. Then I go investigate the other one. So I look over here. I go, all right, do I need an a plus 5? Yes, I do, because there's not one down there. So I'm going to write the a plus 5. Then I look, do I need the a minus 5? No, I don't. I already have one. I don't need that one. So again, to review that process, we got to get it built correctly. I wrote the first one down, looked here and went, do I have this guy? No, I don't. I need it. A plus 5. Do I have the other one? Yeah, I do. I've already got it. I'm good. There's my common. Now I build the numerator. Right, so my numerator is going to start with an a minus 3. Here comes my comparison. Old, new. It's what am I multiplying this by to get this? Also, it's visual. I see these two. What's different down here? This guy. It's a plus 5. So I'm going to have to multiply the a minus 3 times a plus 5. I go to the right half. A minus 9. Old, new. So I'm looking and going, all right, what's different down here that's not up here? Well, it's the a. That means I've got to multiply this one by a. Everything else after that is stuff you're pretty comfortable with. I'm going to multiply it out, combine like terms. Yeah, we make mistakes, but we know how to multiply those. We know how to distribute an a and put like terms together. That's not new to us. This is the key. We got to get this built correctly. Make sure things are factored. Get your common if it doesn't have one. Write the first one down. Look over. Hey, do I need it or not? That's what my thought process is. So here we go. Multiply the top out. A squared plus 5a minus 3a minus 15. Boiling that out. Plus a squared minus 9a. All over a minus 5, a plus 5. Let's see here. I've got a squareds I can put together. That would be 2a squared. That would be 2 minus 9 is negative 7a minus 15. Now look at that numerator. I don't know if that numerator factors or not, 2a squared minus 7a minus 15, but I better think about it. Because if it factors and reduces, I've got to make sure it's reduced. So I get that square, and that should be immediately entering into your mind. Say, wait a minute, that might factor. Let's take a look. If it factors, 2a A. 15 would be 3, 5. Plus minus, let's see, negative 10, positive 3 is negative 7. That factor. And more importantly than just factoring, then a minus 5 also cancels. So at this point, you're kind of going back to what we did before. We've got to see if we can simplify something. Sometimes they don't simplify, like this guy here. Sometimes they do. Just like when you use just numerical fractions, you got an answer. Sometimes they reduce, sometimes they did. Here the a minus 5s cancel. So my final answer is 2a plus 3 over a plus 5. I wish I could tell you that none of them are ever going to simplify when you're done. That's just not true. I wish I could tell you you could look right here and tell from the beginning if it would simplify in the end. There's no way. Okay? I'm working the process. I end up with a square. Whoa, that might factor. Let me check it out. Okay? This one was also a square. Just didn't factor. So it's not going to simplify. That's okay. We're going to run into some that do and some that don't. All right, let's look at one with 3. Let's go 5 over 3x minus 6 minus x over x minus 2 plus 2x plus 3 over 5x minus 10. Again, looks like a mess. You can tell right away I don't have common denominators. I can also tell right away that I need to factor 2 of those denominators. So I can take a 3 out of this first one. 3x minus 2. 5 out of the last one. 5x minus 2. Then I can build my common. Again, I know it looks kind of like a mess, but I need it simplified on the denominator so then I can look to figure out what the common is and build the numerator. We have 3 fractions now. We're not going to change our process. We always get in the habit of doing a process and it works, and all of a sudden we see something different and we quit. Stick to it. Our process for the common. Write the first one down. So I'm writing the 3 and the x minus 2. That was the first one. I look at the second one. And I have to decide, do I need this x minus 2 down here? No, I do not. There's already one there. I don't need it. I go to the third one. Do I need the 5? Yeah, I need the 5. Do I need the x minus 2? No, I don't. It's already there. There's my common. Now the numerator. 5. Here comes our visual piece. What is down here that's not up there? That would be the 5. So this has the 3 and the x minus 2. Doesn't have the 5. Minus x, go to the middle one. What's in that common down here that's not up there? Well, that's the 3 and the 5, which I'm just going to go ahead and write that as 15 because 3 times 5 is 15, but it's the 3 and the 5 that's missing. The last part, the 2x plus 3, old, new, 3 is what's different. I had a 5 and an x minus 2. I don't have the 3. There goes my 3. Having 3 things to add or subtract isn't making it any more difficult. It's the same process. Don't let that get to you. It doesn't matter how many fractions we're adding or subtracting. Now let's work to simplify it. That's 25. minus 15x plus, let's see, 6x plus 9 over, I'll go ahead and make that a 15. 3 times 5 is 15. 15x minus 2. And then up top, let's see, negative 15x plus 6 is negative 9x. 25 and 9 is 34 over 15 and x minus 2, and nothing simplifies there. I don't have any kind of common factors there. Okay there? Let's look at one more here. X over x squared plus 11x plus 30 minus 5 over x squared plus 9x plus 20. What should be, as you're writing that down, what should be the very first thing we do? What do you think? What should we do first? Factor. Yeah, we've got to factor those denominators. We need to know what we're dealing with. We need them factored out in their simplest terms, so then we can look at it and figure out the common. We can tell they're not like denominators. That's easy. I can see that. But I need to know what I'm dealing with. Factor. Here we'd have x plus 5, x plus 6. And over here, x plus 5, x plus 4. Again, not common. That's okay. I got to build my common now. Again, it looks like a mess because I got 2 on the left, 2 on the right. Stick to the process. To get your common, first step, write the first one down. X plus 5, x plus 6. It's worked every time so far. It's going to continue to work. I get that first one down because if it's here, it's part of the common. Now I go to the right. Do I need the x plus 5? No, already got it, right? Good. I do need the x plus 4, though. I don't have it down there. So again, I see an x plus 5. Hey, I'm good. Oh, I don't see an x plus 4. Let me get that guy down there. There's my common. Common's built. Build the numerator. Then it's back to the grunt work of putting everything together. So this x, I got to decide if I'm multiplying that x by anything. Old, new. What's in the common that's not up here? The x plus 4. Minus 5. Old, new. I'm looking at it. Wait, what's down here that's not up here? Well, the x plus 6. Everything else is putting it together and seeing if it simplifies. I've got the fraction built. I've done the subtraction process. Let's see here. This will be x squared plus 4x minus 5x minus 30. X plus 5, x plus 6, x plus 4 on the bottom. Out of the way. Let's see, up top I can combine the 4x and the minus 5x. So that would be x squared minus x minus 30. Over my common denominator, 5, 6, and 4. And there's that square showing up again. So what should immediately enter your thought process is, hey, that might factor, and if it does, it might simplify. I better check it out. And x squared minus x minus 30, that does factor to x plus 5, x minus 6. We've got to factor quite often. The nice thing is there's no new factoring rules coming, but those old ones are going to keep coming back. And that takes us back to now this will simplify because I can cancel an x plus 5, making my final answer just the x minus 6 over the x plus 6, x plus 4.